In this video, we're going to be covering automotive lighting. I will do this in 2 sessions rather than doing 1 session that ends up being over an hour long. We're going to have a light bulb that's on there, obviously. It can be incandescent, it can be HID, it can be LED, whatever type of bulb they have on there. They all have to have both power and ground. We're going to find circuits that are power side controlled. You'll also find circuits that are ground side controlled. There are some series circuits, so it's just a single bulb that's wired on there. Most of them, though, you'll find are parallel circuits, either power side or ground side controlled. And we even have a series parallel circuit, which we're going to take a closer look at right here. From the headlight switch, we have the off, park light, or headlight position. You can see that there's continuity on both of those. That's going to bring power over to our rheostat. On many cars, it'll be a potentiometer. This is a variable resistor that is going to put power out to our dashboard illumination. Not just that, but all the lights in the interior that will dim and brighten with the dash lights. That's what you're looking at here. First, turn this in the on position. We're going to have a lot of resistance. Bulbs will be dim. As you decrease the resistance up here, the lights will get brighter. If none of the lights work, first thing you want to check is the fuse. If the fuse is good, get to the bulb that's easiest to get to, check for power, and check for ground. If there is no power, that's the side of the circuit you're going to be checking on, or if there is no ground, be checking over on that side. Chances are when you fix the one, it'll fix all of them. If you have one light out, that's normally going to be a bulb that's burned out. Replace that one bulb. If that doesn't fix it, again, check for power, check for ground. But now, so if this top one here is the one that's out, your problem is going to be just from there. And again, you'd be looking for an open or for really high resistance. If you have bulb or bulbs that are dim, you're going to be looking for resistance with the bulb in there. Check to see if you have battery voltage. If you do have battery voltage, then that means the problem is on the ground side. If it's less than battery voltage, then the problem is going to be on the power side. Most all the lighting now on the cars has gone to computer control. Looking at this module here, which is the hazard flasher module. But again, most of the time as you're dealing with cars, when you come across a module, what that means is that it is a computer. This is our input, daytime running lamps. Computer is going to have power, ground. Here's the input, and the output from this one is going to be from the F and the K terminal. From the F terminal is A. It's going to come down to here. K terminal is B, going to come to here. Each one controls the light. When the daytime running lamps are on, these are the 2 lights that are going to be on. The reason that they're individually controlled is because this is also the turn signal. So on this particular vehicle, your daytime running lamps are also your turn signal lamps. Looking at the different lamps, we're going to go way back, the bayonet style. This one is 1156. It's a single filament light. The aluminum part right here is the negative connection normally. The contact down there at the bottom, you can see it better over here, is going to be your positive connection most of the time. From the filament, this filament in here is just like this one here. One side of the filament is going to be connected up to the housing there, the other side to this terminal. Now 1157 is a dual filament. One side is going to be connected to this aluminum housing here, and then the other connections are to these 2 terminals down here. These knobs that stick out on the side on the 1156 are the same height. Doesn't matter which way it goes in. On the 1157, they're offset. The idea was to prevent you from putting it in backwards. People will still put it in backwards. If they do, it's really hard to pull out of there. It's also going to work backwards. When the dimmer filament, such as the tail lights, are supposed to be on, it'll be bright. When the turn signal or brake comes on, then the dim filament comes on. That will also make the flasher not work correctly. The industry then changed over to this style of bulb. This one is a 194. This is probably the most common bulb that's used on the car. It's used for dash lights, side marker lights, license plate lights. Single filament. It's a small bulb. There's a 168, which physically looks the same, has the T10 socket that it goes into, but the 168 is a little bit brighter. This one is 3156, replaced the 1156. This one is a 3157. They have a 3057, 3157, 4057 that replaced the 1157. They're very similar. They will actually interchange. On many vehicles, you can get away with putting in a replacement one. On some of them, where you have a lamp outage monitor, that little bit different resistance can be enough to tell you you have a burned out bulb when it's actually the wrong bulb that's in there. Next one is a 6411. This is typically seen for like a license plate light on some of the imports or an interior, your dome light. The 921 physically is much larger than the 194. Some of the lights are colored, like they're showing right here. This would be a 194A or 194NA. The A is amber, NA is natural amber. Then if you had a red, it would be an R. These are your trade numbers. If it has a letter at the end that designated that it is a colored, and this is not an exhaustive list. This is just some of the more common bulbs that you'll come across. There's a whole bunch of different bulbs that are out there. Each of those bulbs can now be replaced with an LED bulb. And this is showing you, this is a 194. This was the 1157, the 641. This was a replacement for the 921. They can be brighter, again, depending on how much money you spent for it. They draw less power, produce more light. I like the color of them better. The problem that you can run into is, especially like for a turn signal light, turn signal flasher just doesn't like the current flow through here, so it'll give you an error, typically flash twice as fast, telling you that you have a bulb burnout when it's really because of this. If you have a lamp outage module, it will typically tell you that you have a bulb burnout. If you're going to put an LED to replace an incandescent, you have to put a resistor in there to fool the computer into thinking it's a regular bulb. Looking at the headlights, the lower left corner here, this is back in the horse and carriage state. This was a kerosene lamp. It had the flame and this reflective surface, and it put the light out in front of the vehicle. When we got to the early cars, some of them still had these. They then went to electric, and you had a headlight that looked something like this. This one is off of a Ford Model A. The bulb that's inside of there would be the equivalent of like a brake light bulb. They have the lens cut so it directs the light. However, that brake light bulb, there's not a whole lot of light that goes out in front of the car. I remember my grandpa telling me stories about working on the farm and this car going by, and he and his friend are going, wow, that car must be going 35. Well, when 35 is your top speed, we didn't need a whole lot of light. As cars continue to get faster, we needed more light out front. In the mid-40s, some guy who I think was politically connected came out with a sealed beam headlight. This whole assembly is your light. The filaments inside of there, this is vacuum sealed. If you got a rock kicked up into here, that rock would, if it cracked the lens, your light would get really bright for just a second and then go out. Replaced a lot of these. And that's what was required on all vehicles driven in the United States, was this round sealed beam headlight. Europeans started to get some really cool aerodynamic looking headlights. In 1975, the federal government finally said, okay, and they allowed you to have a rectangular sealed beam headlight. So you'd either have 2 round or 4 round or 2 rectangular or 4 rectangular. Some of them were dual filament inside there. And that's what was required in the United States. It wasn't until '84 that NHTSA, National Highway Traffic Safety Administration, finally allowed the composite headlights that you see on most all the vehicles today. The bulb inside there is going to be a halogen bulb, so instead of being vacuum inside there, it is going to be some sort of gas that's going to cause the filament to burn brighter, give off different colors depending upon the type of gas that's inside of there. The headlight assembly is going to be plastic most of the time with the replaceable bulb. If the housing gets cracked, it doesn't burn out the bulb. You will see condensation on the inside of these at times. That does not mean that there's something wrong. What's going to happen when the bulb turns on, it's going to get really hot. There's vents that are on here that the air, instead of building up pressure, it's going to allow the air to escape. As it cools down, it's going to bring the air back in. Sometimes the air that brings back in is going to bring some moisture with it. So a little bit of condensation on the inside of there is not a problem. When it turns on, the bulb's going to get it hot and the condensation will disappear. If you see water inside there, so this thing is a quarter full and there's guppies swimming around inside there, that's a problem. That means the housing is cracked. For a customer vehicle, I am going to tell them that they need to replace it. If it's my own or a friend's vehicle and they don't have the money, I'll drill a little hole at the bottom and let the water drain out. I've also seen where the water gets inside there, you'll find the glass inside of it, and that's because as they're driving along, you hit a bump, water splashes up, hits that bulb, and the bulb explodes. On the projectors, this style right here, I was helping a guy. He had a headlight system, something like this, and he replaced it with a custom one that had the projector. He had replaced his incandescent with a HID, so man, it was nice and bright out in front of that vehicle. Then he put this custom headlight on there and had the exact same bulb, and man, it was darker with that projector than it had been with an incandescent light. UV damage, they're all going to be fogged over. Give them enough time, enough exposure to sunlight, they're going to fog over. There's a lot of kits, such as this one here, that will give you the sandpaper. It'll give you like 1,000 grit, a 3,000 grit, and then this polishing. And it can take that off and clean it up, man, and make it look really nice. And it's going to stay really nice for a few months, and then it's going to fog over again. The reason is because they put a clear coat over the lens. That's what fogged up, was that clear coat. You just sanded it off, so the protection from UV is now gone. To do this right, pull the headlight off. Don't try to do it once on there. Sand it down, and typically I'll use like 1,000 grit to sand all of that clear coat off of there, get everything smoothed off, then use like a 3,000 grit. This stuff here is the best stuff that I found. It's going to put the clear coat back on. There's multiple different products that are out there, and I've tried several of them. This is the one that I like the best when you spray it over. These are $20-some for a can, and I found that I can do 6 headlights with it pretty easy. What I will typically do is wait until I've got 2-3 cars that need to be done. There's 2 different products in here that need to be mixed together, and once you puncture that, it has to be used up within 12 hours. HIDs. I didn't look up the year that HIDs were allowed. The high intensity discharge. It's really nice technology. I really like the bulbs. There's no filament inside there. What you have is 2 electrodes, and you're going to arc between there, and that's what's going to produce your light. 35 watts instead of a typical 55 watt for the low beam. However, it's going to give much more light, and it's going to give light across the light spectrum. If there's somebody walking along the side and they have any sort of reflecting clothes, with these lights, man, it makes it glow. They're high voltage in order to get that to come across there. And that's what you're looking at over here. This is a ballast. Then some of them will also have a starter because you need the higher voltage. And depending on where you read or what you read, they're going to talk about tens of thousands or hundreds of thousands of volts. But it is thousands of volts to arc across there. I've read so many different things, I don't know which one is true or whether depending on the design. The other nice thing with the HIDs is you can get the different colors, and they're actually referenced as temperature, so 4,300 Kelvin to 3,000 Kelvin, depending on the light. The technology that they're using now has gone to LEDs. This up here, you can see they've got the halogen light, which if you compared a halogen light to an incandescent light, this halogen would look white, and the incandescent would look yellow. However, when you're comparing LED to halogen, you can see the LED looks much brighter, much whiter, also draws less power. The vehicles today have all kinds of different designs for the LED lighting. They have a mixture of LED and incandescent, or it may just have the LED. The LED is nice in that you can do all kinds of different designs. It gives a lot of light for small power consumption. The advantage to an LED over an HID is HIDs turn on very slow. The LEDs are near instant on. There's a technology that's actually here on a couple high-end European vehicles, and that is the laser lights. Yeah, I don't know all the advantage, disadvantage of laser lights or whether it's just a cool new technology. What I do know is that just the headlights add $8,000 to the price of the vehicle. They're going to need to bring the production up, get the price down before you'll start seeing laser lights on more vehicles. Headlight switch. Again, we're looking at a 3-position switch of our off, park light, headlight. We're just looking at the headlight position here for our headlights. We're not looking at the park lights, tail lights, or anything like that. Next, it's going to come to the dimmer switch, which we're going to have low beam or high beam. So the dimmer switch is on in both positions. This shows it as a knife blade switch, so it's actually going to shut the low beams off before it turns the high beam on. You'll always see it drawn like this. That's not the way it's designed. It is actually a make before break connection. It's going to turn the high beam on before it shuts the low beam off, or if it's going the other way, it's going to turn the low beam on before it shuts the high beam off. On this particular one here, it is a 4-headlight system. However, for low beam, it's going to be just 2 lights. High beam is going to be just 2 lights. One thing I do want to talk about on this one here, this vehicle has a redundant ground set up between here. Manufacturers have changed over to that. What that's going to do is if you lost this ground right here, you would never know it. It's going to ground over at this one. If you didn't have that and the wire broke right here, these lights will still work. What's going to happen is from the low beam, it's going to come down to our low beam here, and we're going to backfeed. It's actually going to come over. This light is going to come on dim. The high beam will come on dim. The low beam will come on dim. And the high beam indicator on the dash will come on. You will find this on taillight assemblies. When you're following a vehicle and they've got just their taillights on, you'll see one side is bright, the other side is dim, and then they hit the brake, and the one side that was dim goes out. The tail light is grounding through the brake light circuit. Then when you put power in the brake light circuit, the bulbs lose their ground, so that side goes dark. Watch for that. Somebody brings a vehicle in, talking about a brake light, and you see that, hey, with the tail lights on, the brake light goes out. That's the problem. Here's another headlight circuit. Down here in the right-hand corner, we see our headlight switch. Again, it's a 3-position switch for off, park, and headlamp. Our dimmer switch over here. And this one has the flash to pass feature. I like Chrysler's name for it. They call it an optical horn. The idea is that you can just flash the lights if you're going to pass somebody. That way they can accelerate at the same time you do. The reason that I brought this headlamp circuit in is because instead of the headlight switch powering up the bulbs, what we're doing here is we're using relays. There's an advantage to using relays even without computer control. I'm going to come back to this circuit here. Let's erase our ink on there. From our circuit breaker that's on here, we're probably going to have 2-3 connections before that, but let's just say we have 1 connection before here. At the fuse, there's 2 connections, like is this the 3. Coming out of the fuse box, a 4th one. Coming to the headlight switch, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 coming out of the bulb, 15, and then 16 at our ground. We have 16 different connections. When the cars get to be 8 to 10 years old, those connections begin to lose some of the tension, they have a little more resistance, and it is not uncommon to find a 1 to 1.5 volt drop across that circuit. On an incandescent bulb, if you have a 10% voltage drop, that bulb is 30% dimmer. An incandescent bulb, the best definition, it's a heater that happens to give off light. Most of the energy is used to produce heat. It's just the energy at the end. A 10% voltage drop dims the light by 30%. When I find vehicles like that, what I do is cut the wire here under the hood, put a relay in. All these different connections control the relay, and then the relay is going to give the voltage right to the bulb. By using the relay from the manufacturer, you don't have that problem. As the car ages, the other advantage for the manufacturer is they changed over to this. When they went to computer controls of the headlight, all they had to do was control the relay from the computer. This circuit didn't have to change. Daytime running lamps. Your vehicle, if it's 30 years old, Even if it doesn't have daytime running lamps, it had the option of daytime running lamps. For decades, Canada has required daytime running lamps. I don't understand why the United States does not require daytime running lamps. There have been multiple studies done. All of them proved that, especially on two-lane highways, there are fewer accidents because our eyes are naturally attracted toward a light, and you see a car coming at you if they have their lights on. GM back in 92, 93 said they were going to make all their vehicles with daytime running lamps. They never did. As I've talked to people, there's a lot of people that have daytime running lamps, and they complain and gripe about them. I don't understand. It's a safety feature. It really does reduce the number of accidents. For the daytime running lamps, they can use the high beams or the low beams. If they do, they dim them down. They will either wire them in series. They will use a resistor to drop the voltage. I've also seen where they put two diodes in series. Again, a diode's going to be about a half a volt drop, so they'll drop a volt or so across there. Or they will duty cycle control. An incandescent light turns on, turns off slowly, so the light is not going to sit there and flicker. They will also, as they're seeing here, this is some of the modern ones, they have the lights on all the time, that's your daytime running lamp. Down here, they were using what's probably the turn signal or a park light as the daytime running lamp. This one here is real confusing. We're just going to focus on the ground. Here's our two headlights, and you can see that both these headlights go to ground. On the other side of the car, left-hand side, the low beam goes directly to ground. However, the high beam, for it to get to ground, is going to come across. This is going to be connected there. I was using two different sheets, and this is the only way I could get it to line up. Then it's going to come over to normally closed switch within the relay, back over to the splice, another splice, and then to ground. Still goes to ground, it just goes through a long path. When the daytime running lamps are on, this relay is energized. Now we're going to put battery voltage on here. I'm going to put battery voltage here, and it grounds there. And that's our daytime running lights on this vehicle using the two high beams wired in series. Automatic headlights, of course, they have to go with everything computer controlled today, which some people will complain and gripe about going to computer controls. However, it does make for things more convenient. It also allows different systems to communicate with one another. When you hit the alarm system, it's nice to have the vehicle flash lights, or when you lock the door, to give you some sort of report that, yeah, the doors really did lock. In order to do that, it's got to be computer controlled. To go with computer controlled, now our switch, which we're looking at here, this one's actually a 4-position, so we have the off, auto, park light, headlight. We're going to add a sensor, which is going to be a phototransistor or a photodiode. This is going to give a variable voltage signal depending on how much light is exposed to it. Come out to your vehicle, you start it up, it's dark. There's going to be a low voltage signal from this, so the computer is going to turn your exterior lights on. Tail lights, park lights, license plate light, headlights, all of those different lights. If you're driving along, red light, and you stop under a street light, you don't want your headlights to be shutting off, so they purposely have a delay built in this. If you're following a car, you can tell if it's got the automatic headlights because they come into a tunnel or they get stopped under a bridge, and after sitting there for a few seconds, all of a sudden, you see all the lights come on. When they come out, it's going to take 30 seconds or more before the lights are going to shut back off. Again, that's because if you're parked under that street light, they don't want to shut the headlights off. The second auto feature that you'll find on some of the vehicles, that's the auto dimming. You can look at this image right here. You can see there's a sensor right by the mirror. This is looking forward. The early ones, it was just a light sensor. If you were driving up a hill, there's a street light up there, it would turn your high beams off because it thinks that's an oncoming car. Over time, this got much more complicated. It became a camera. It is supposed to be able to identify the light difference between the headlight of an oncoming car and a street light. I rented a Dodge truck that had this auto dimming feature. I was driving along, turned on the high beams, came up to a street sign, and this street sign reflected my own headlights back toward me, and the high beam shut off. I wasn't too impressed with that system. There was probably an adjustment on there, but I didn't have the vehicle long enough to be able to go through and play with that. We have auto on-off, also auto dimming with the headlight system. Auto leveling headlights. Let's see if we can get this video to work. So that was a Mini Cooper. To adjust these headlights, inside the headlight assembly, they have a reversible motor. When you start up the vehicle, it's going to cycle through. Computer wants to know what position it's in. It's also going to test the movement. So it makes the headlights go down and then come back up to the position. The purpose of having this, let's say that you're driving a Mini, you put 2 people in the back and stuff some cargo in there. The back of that car is going to squat down. There's sensors on the vehicle, typically on the struts. This is going to see that the back of the car is squatted down, so it's going to lower the headlights so the headlights aren't in the eyes of the oncoming vehicles. What they have now gone to, besides having the auto leveling, they also have the adaptive headlights. With the adaptive headlights, you can turn the steering wheel and the headlight is going to move. Back in the 70s, what they did was on some of the cars, and this carried on through the years, when you turn on the turn signal, it actually lights up a light that's on the front corner of the vehicle to light up where you're going to turn to. That was a nice feature. Well, what they're doing now is when you go to make a turn, it's going to take the headlight. If you're making a right turn, it's going to take the right headlight and it's going to swing it over so that you can light up where you're turning to. Left side also, they've also talked about this system becoming predictive. And what they're going to use is your GPS. You're traveling along the road. Computer knows where you're at. It knows that there's a turn on the road. Before you even get to the turn, the headlight's going to swing over and light up into the turn so you can see what's coming. Down here, we're looking at a Hoppy headlight system. This is probably still the most common headlight aimers that are out there. For these to work, your headlight has to have these 3 nipples on the lens. The adapters are going to go up against there. If you have the aerodynamic headlights, there are special adapters that are going to adjust for that to be able to put these on there. This viewing port right here has 2 mirrors. You're going to look through there at a target over here, and then you're going to adjust horizontal until you get the targets to line up. Same thing on this side. There's a bubble on each of these. That's going to be your vertical adjustment. If you don't have the Hoppy headlight aimers at the shop that you're working at, you can use the mark on the wall. But be careful because one mark doesn't work for all vehicles. To do this correctly, you first of all need to make sure all the tires are aired up to the proper pressure. They don't have a heavy load in the back of the car unless they drive around all the time with that heavy load. Then you need to measure from the floor to the center of the light. You're going to put a mark at that same height. You need to mark from the edge of the vehicle, or measure from the edge of the vehicle to the center of the light, be lined up perpendicular to the wall, measure from the side, or what's equal to the side of the vehicle, over, and you're going to put a vertical mark. Then measure the distance between the 2 headlights, put another mark there, and that's your target. If you're doing low beams, if you're aiming it from the low beams, you need to aim low and to the right. If you're doing high beams, right dead center on your mark. You will also find vehicles, headlights aren't adjustable. This is showing you down here the headlight adjustment. This is one style. This is designed to get a Phillips screwdriver right down in here, and the Phillips screwdriver, as you turn it, grabs these teeth and turns this. If there's room, you can also get a ratchet down inside there with a socket to get on that, but it's much easier with the screwdriver. There should be 2 of these, one for a vertical adjustment, one for horizontal. You'll come up to one vehicle and there'll be none of these nipples on there. If the headlight is adjustable, then you got to do it strictly by the wall method. You'll get another vehicle, the headlight's off, and you look and look and look, there are no adjustments for it. And what the manufacturers figure is that as long as this car hasn't been hit, those headlights are aimed. If the headlight is off, it needs to go to a body shop to get that fixed. And we're going to stop here, and we'll pick up the rest of the exterior lights on the next video.